All right, Matt, here we go. We got lesson 2-3, rates of change. So we're going to still look at slopes a little bit, maybe look at them in a different way than we've seen before. We talked about slopes on the last lesson that we could do slope triangles from them. So this week we're going to look at just tables and how slopes relate to lines. So linear equations to start off with. Well, the first four letters in the linear equation is line. So linear equations are equations that make lines. So if you graph the solutions to a linear equation, it will make a line on your graph, much like this one down there. Now, linear equations always have what we call a constant rate of change. Constant means it doesn't change. So their change doesn't change. It changes the same amount every time. So that means any 2 points on a line will always give the same slope. So since the rate of change, which is another way to say slope, since the rate of change is constant, that means that it doesn't matter which 2 points you pick, you're going to get the same slope. And let's go ahead and prove that out here real quick. Let's find, we've got a line. So again, the line should have a constant rate of change, meaning any 2 points should give me the same slope. I've got 4 different points on a line. Let's go ahead and find slope triangles for these points, A to B. A to B, slope triangle. Looks like the y value is increasing by 2, while the x value increases by 1. So AB is 2 over 1, or just 2 for our slope. Next one, B to C. All right, B to C. It looks like 1, 2, 3, 4. It looks like it's increasing by 4 on the y-axis and increasing by 2 on the x-axis. So my slope, the change in y is 4, the change in x is 2, rise over run. But this also reduces to 2, same exact slope. All right, let's try C to D. 1, 2, 3, 4, 5, 6. The y value is increasing by 6. 1, 2, 3. The x value is increasing by 3. Jeez. All right, so we get 6 over 3. Reduces to 2. Still the same exact slope. If you still don't believe me that they have a constant rate of change, let's keep going. A to D. Oh dear. A to D. That's from here all the way up to here. Let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's going up 12. 1, 2, 3, 4, 5, 6. Over 6. Change in y is 12. Change in x is 6. Still reducing to 2. And then B to D. B to D. Oh dear. It's going up 10 and over 5. Still reduces to 2. This is what we mean about a constant rate of change. It didn't matter which 2 points I picked. When I reduced the fraction for slope, I got the same slope. Every line has the same slope no matter which 2 points that you pick to calculate the slope. So tables can also be used to find the coordinate, coordinate points and to find slopes from. So here's a table. It says when x is -4, that y is 6. So that means go back 4, down 6. That's this point right here. That's point A. -3, 4, back 3, down 4. That's point B. -1, 0. That's point C. 2, 6. That's point D. So these are the points that I have graphed over there. And when you have a table, and if you know that if you have a table and you know that you have a line, So as long as the table represents points on a line, you can pick any 2 points on this table to see what the slope is. So I can do over here, from 6 to -4, the y is increasing by 2. The x is increasing by 1. Change in y over change in x, or rise over run, I would put 2 in the numerator, and I'd put 1 in the denominator. So we don't really have to graph these. If we just look at a table, we can find out what our rate of change is, or our slope. Okay, let's practice that with these tables down here. These all represent a line. So I can see that my x value here is increasing by 1. It's increasing by 1 again. It's increasing by 1 again. The y value, decreasing, it's going down by 3. -2 to -1, that's going down by 3. -1 to -4, down by 3. So if I want to find my slope for this, I would do the change in the y values divided by the change in the x values. The y values are decreasing by 3 as the x values are increasing by 1. So my slope would be -3. Next one, from here to here, my x values are increasing by 3. From here to here, still increasing by 3. Here to here, still increasing by 3. For my y values, -6 to +1, that's getting bigger. That's getting bigger by 5. -1 to +4, increasing by 5. 4 to 9, increasing by 5. So I can see that as my x values are increasing by 3, my y values are increasing by 5 on a consistent basis. It's constant. So my change in my y values divided by my change in my x values would be 5 over 3. The y's are changing by +5 as the x's are changing by 3. All right, try out the last one. You can pause right now. Try it out. All right, hopefully you're back. You paused and you tried it out. Here we go. -1 to 3, that's an increase of 4. 3 to 7, also an increase of 4. 7 to 11, still an increase of 4. So my x's are increasing by 4 consistently. My y values are decreasing by 1. -4 to -5, that's a decrease of 1, decrease of 1, decrease of 1. So as my x values are increasing by 4, my y values are decreasing by 1. So my change in my y values over my change in my x values would be -1 over +4. -1/4 is my slope. So I don't need a graph and to do the slope. I don't have to just do slope triangles. I can look at just a table and find the slope by looking for the constant rate of change, comparing the y values to the x values, the change in the y values to the x. All right, that's all I got. Math hard. I'll see you later. Bye-bye.